This lecture is going to review how to go over molar mass calculations. As a reminder, we have relationships between the number of atoms or molecules and the number of moles, and then the mass of that substance. If we want to go between the number of things, atoms or molecules, and the number of moles, we're going to use the conversion of 1 mole is equal to 6.022 times 10 to the 23rd, Avogadro's number. And anytime we want to go between number of moles and mass, we have to use the molar mass of that substance. So if we want to go starting with atoms, to go to the number of moles, we would then divide in that case by Avogadro's number to end up with moles, and to go from moles to mass, we would multiply by the molar mass. To go in the opposite direction, if we start with the mass of a substance and we want to get to moles, we would divide by the molar mass, and if we have the moles of a substance and want to get to the number of atoms or molecules, in this case we would multiply by Avogadro's number. So in chemistry, when we're dealing with formulas and molecules, we have more than one atom present in a molecule, and so we can review our molecular formulas is a representation of that molecule that shows us how many of each type of atom are present. So we have two examples shown below. We have H2O for water and CH4 for methane. And water, we can see there's 2 hydrogen atoms and 1 oxygen atom in one molecule. And for methane, we would have 1 carbon atom and 4 hydrogen atoms in one molecule. We could also say that as there are 2 moles of hydrogen in 1 mole of water, and there is 1 mole of oxygen in 1 mole of water. We can sometimes, instead of giving the molecular formula, we're given the structural formula or the Lewis structure, which shows how the atoms are connected, which gives us the same information in a slightly different form. So let's go through a couple quick examples of some calculations with molar mass, and we'll start off with what is the molar mass of methane. And so in order to get the molar mass, we're going to determine how many of each type of atoms there are, and then just sum all of the atomic molar masses of each atom. So for example, we have 1 carbon atom. That carbon atom is 12.01 grams. So we'll add to that the mass of 4 hydrogen atoms. Each atom is 1.008 times 4, so the overall molar mass is 16.04 grams per mole. We can use this value if we have given some problems. So 2 types of problems we might find are calculate the mass of 2.85 moles of methane. So in this case, we are given the number of moles of methane, so we always want to start with the number that's given. So we'll start with 2.85 moles. We want to go to grams, and so what we're going to do is we're going to multiply by the molar mass. Our moles get crossed off, and we end up with 45.7 grams of methane. On the other hand, if we have a problem that says how many molecules are present in 2.60 grams of methane, note this is actually a 2-step conversion. We first have to convert grams to moles, and then once we have moles, we can go to the number of molecules using Avogadro's number. So we'll start off, always start with the number that's given, 2.60 grams, and then we're going to divide by the molar mass. So 2.60 times 1 divided by 16.04 grams, and then we can multiply that by Avogadro's number divided by 1 mole to get our final value of 9.76 times 10 to the 22nd molecules of methane. So here's another problem that you might be given. So this one asks, determine the number of moles of aluminum present in 78.45 grams of aluminum sulfate, and then determine how many atoms of aluminum are present in this sample. So please pause this video, take a few minutes, work through the problem, and then we can go through the answer together. Okay, now that you've attempted the problem, let's go through this together. And the first thing we have to do to solve this problem is we're going to need the formula for aluminum sulfate. So in then we're going to need to calculate the molar mass of the formula. So the formula for aluminum sulfate, we'd have to look up our polyatomics and find out that aluminum has a charge of +3, sulfate has a charge of -2, so the overall molecular formula is Al2SO43. To get the molar mass of this, we're going to have to add up all of those atoms collectively to get our molar mass. And when I did this, there's 2 aluminums, each at 26.98 grams per mole. There's 3 sulfurs at 32.07 grams per mole, and there's 12 oxygens at 16 grams per mole. So I got a molar mass of 342.17 grams per mole. Next, what we need to do is convert the number of we need to calculate the number of moles of aluminum sulfate present in that 78.45 grams. So we'll start with the number that's given, 78.45 grams, and then we need to divide, in this case, by the molar mass. So 78.45 grams of aluminum sulfate divided by the molar mass of 342.17, and we can get our moles of aluminum sulfate to be 0.2293. That's how many moles of aluminum sulfate we have. We now need to determine how many moles of aluminum are present. And notice for each molecule of aluminum sulfate, there's 2 atoms of aluminum. So if we have 1 mole of aluminum sulfate, there must be 2 moles of aluminum. So we're going to need to calculate the moles of aluminum sulfate in our sample, and we can do this with what's known as a mole-to-mole conversion, or ratio. And so we're going to start with the 0.2293 moles of aluminum sulfate, and we know there's 2 moles of aluminum per every 1 mole of aluminum sulfate. And so the total moles of aluminum present is 0.4586 moles of aluminum. And so finally, now we can calculate the number of atoms of aluminum by multiplying the moles by Avogadro's number. And so we end up with 2.761 times 10 to the 23rd atoms of aluminum present in this sample. So there's a lot of calculations on this slide. Please go back, check, make sure you understand, make sure you can calculate using your calculator these same answers, and let me know if you have any questions. Thank you.